Okay. So good morning students. So already we have discussed about design steps for laterally unsupported beams. So now we will check about example problem to solve the laterally unsupported beams. So first keep in mind. So we should keep the design steps in mind. Okay, we should follow the step-by-step procedure to solve the problem. So keep in mind the design steps. So first, a proposed cantilever beam built in a concrete wall free at one end. So one end free means it is a cantilever wall beam. It supports dead load of 20 kN meter and live load of 10 kN per meter. Length of the beam is 5 meters. So assume the necessary data. Okay. So this is the problem for which we have to solve on laterally unsupported beams. So already we know step 1 loads. Step 1 loads. So dead load, live load, total load 30 kN and the factor load is 30 into 1.5, 45 kN meter. So how to calculate the loads means how to calculate the laterally unsupported beams. See, so first step also very easy and first step is same for laterally supported and laterally unsupported. So second step, what is the second step? To maximum bending moment and maximum shear force. So what is maximum bending moment and maximum shear force? So maximum bending moment for cantilever beam with UDL. Cantilever beam with UDL, the formula is WL square by 2 and the shear force for cantilever beam was WL. Okay, so here WL square by 2 is 45 into L. What is the L of length of the beam? 5 by 2 and 45 into 5. So which we get the answer as 562.5 kilonewton per meter and 45 is how much? 225 kilonewtons. So step 2 is calculation of bending moment and shear force. Step 1 is loads. So step 1 and step 2 are similar for laterally supported and laterally unsupported. So now step 3, plastic section modulus. Plastic section modulus. Okay. So now plastic section modulus. So what is the formula for ZPZ required? M into gamma m naught by f. M into gamma m naught by f5. So what is the value for m? Maximum bending moment is 562.5 into newtons 10 cube into gamma m naught 1.1 by 250. So 562.5 into 10 cube into 10 newtons into 1.1 by 250. So we will get the value as 2475 into 10 cube mm. Sorry, this is 10 power 6. Why? Because kilonewton per meter. So newton per mm. So we will get 2475 into 10 cube mm cube. So what is the next step? So we should take the possible section. We should take the possible section for the plastic modulus, which is 2475 into 10 cube. So select the value of section which is greater than ZPZ. Select the value of the section which is greater than ZPZ. Okay, which is greater than ZPZ. Not right. Okay. So step 4 is selection of section. Selection of section. Now let us try. So you should write let us try. So open page number 138 to 138, 140. So page number 138 to 142 in code book. So see the value for ZPZ as 2475. So take the value of section which is greater than 2475. So now I am writing the section. Let us write ISWB 600. ISWB 600 at the rate 1311.59 Newton per meter. So 1311.59. So once listen. So here we have the value of ISWB 600, but in the steel table book or code book you don't have this value. So for this value we should write. So for suppose ISWB 600, some value will be there, some x kg per meter. The value will be in some x kg per meter. So 1 kg is equal to 9.81 newtons. 1 kg is equal to 9.81 newton. So multiply the x value into 9.81. That will give answer in Newton per meter. So this one will be converted. Okay, this one will be converted to Newton per meter, and the value will be this one. So multiply that weight value x with 9.81, and we will get the value in Newton per meter. Okay. So now we will write the properties. So what are the properties we have to take for ISWB? What are the properties of? Write the properties of ISWB. D 600 mm, BF width of flange 250 mm, TF 21.3 mm, thickness of 11.2 mm, radius 17 mm, like that. ZDZ, ZPZ, D. So here the formula for D is H minus 2 into TF plus R1. So already we know H means height, 2 into TF plus R1. So we will get the value of 600 minus 2 into TF 21.3 plus R1 17. So we will get the value of 523.4 mm. So this is the D value, and maximum moment of inertia of IZ value. So these values are in code book and table book also. These values will be in code book and table book also. So this is the step 1 loads, step 2 calculation of bend moment and shear force, step 3 plastic section modulus, and step 4 let us try the section. So selection of section. Okay. So these 4 steps are same, common to laterally supported and laterally unsupported. Okay. So now we will go to step 5. So in some textbooks, the step 5 is common. So step 5. So step 5 is nothing but the weight, the taken load value is safe or not. The load which you have taken for the section is safe or not. So calculating the load which is safe or unsafe. So self weight is equal to 1.5 into 1.311. So how we will get this value? So 1.311. So how we will get this value? 600 at the rate 13119 Newton per mm. So this is the value which you have taken. So this one comes 1.97 kilonewton per meter. kilonewton per. So this is the value in newtons. I have converted in kilonewtons. So 1.97 kilonewton per meter. So maximum bending moment is, so already we have calculated one bending moment, that is 562.5 plus. So this is the load 1.97 into 5 square by 8. So here we are taking one simply supported beam. Let us consider one section. No, so this is the proposed cantilever beam, the maximum minimum for proposed cantilever beam, plus the self-weight which is on the beam or overall wall is UDL for simply supported. So 1.97 into L square 5 by 8. So which we will get the value of 568.65 kilonewton meter. 568.65 kilonewton meter. So plastic section modulus. So plastic section modulus m into gamma m naught by Fi. M into gamma m naught. So m is nothing but 568.65 into 10 power 6 into 1.1 by 250. So which we will get the value of 2502.1. 2502.1 into 10 cube mm. So this is the check we should do for which is less than ZPZ. Which is less than ZPZ. Okay. So this is the check we should do. This is the check we should do for step 5 for laterally unsupported is. So is the section which is suitable or not? So the value must be less than ZPZ. The value must be less than ZPZ which we have taken. Okay. So it is which we have taken means ZPZ means, so for the section ISWB, which is for ISWB 600. So for the section which we have taken should be less than. So for section ISWB the value of ZPZ is 3988.66. 3988.66 into 10 cube. So which is less than. Okay. So this is the step 5. So now step 6 is same. Step 6 is same. So step 6 section classification. B by TF, D by TW. B by TF and D by TW. Therefore B by TF is equal to B 125 by 21.3. Why? Because B is equal to BF by 2. Already we know the value of BF by 2. So that is equal to 5.86 less than 9.4 epsilon naught. Next, D by TW. D by TW is already we know section from section properties 523.4 by 11.2 which is 46.57 less than 84 epsilon naught. So this is the values for section classification D by TF and D by TW. So from this which we know section is plastic. Section is plastic. Okay, the section is plastic. So section step 5 with same similar for laterally supported also B by TF and D by TW. So we will get the value of BF by 2 that is 125 by 21.3 and D by W 523.4 by 11.2. So this is the section which is plastic from table number 2 page number 18. Okay, from table number 2 page number 18 we can know the section which is we consider which is plastic or non-plastic or semi-compact So main now we will go for step 7 design bending strength. So main concept for design bending strength. So this is the formula page number 54. So while you go to page number 54 whole formulas for the problem which is required are there in page number 54. Okay, so I have already told to calculate the laterally unsupported beams, the formula should be from downwards to up. Downwards to up. Why? Because first starting formula, the unknown parameter will be in second. Again from second we have to go to third. So first we should know the value for last one, so we can solve the problem. So first here MCR is equal to MCR. So please, while doing this problem, open your code book page number 54, laterally unsupported beams, and do it. Okay. So MCR is equal to root of pi square E IY by LLT square into GIT plus pi square E IW by LLT square. So this is the formula. Here the unknown parameter. So now we will calculate the unknown parameter. So first one IT, that is summation of B. So that is nothing but BD cube by 3. Summation of IT. Okay, IT. That is summation of B into T cube by 3. So we should calculate the I section properties. So I section. Keep in mind I section. So two flanges. So two flanges now, that is 2 into 250 into 21.3 cube by 3. So for the flanges 250 into 21.3, no, 2 into 250 into 21.3 cube by 3 plus web. So this is the height of web. Overall height minus web. So now I am writing it here. Web. So web is nothing but 600 overall minus 21.3 into thickness of web cube by. So this is the value for IT. By solving we will get the value of 1.88 into 10 power 6 mm power 4. 1.88 into 10 power 6 mm power. So two flanges, 2 into 250 into 21 cube by 3, and web height and thickness. So IT we know, LLT is equal to, already we know, 5000 mm. So length of the beam 5 meters, this is in mm, 5000 mm. So next G. So this is standard value, modulus of rigidity 76.923 into 10 cube Newton per mm square, 10 cube Newton per mm square. So this is the standard value, for modulus of rigidity G. So LLT into G. So IT. So we know the value of LLT, IT and G. So now again we don't know the value of IW. Don't know the value of IW. So only this is the tough step to calculation. That's all. Okay. Now we don't know the value of IW. So IW is equal to, the formula for IW is 1 minus beta F into BF into IY into HF square, which is in page number 129. Page number 129. Okay, page number 129, I minus BF into BF, beta F into IY HF square. So here IY is equal to, we have 4702.5 mm into 10 power 4 mm power 4, which is in table book or code book. Next, beta F is equal to 0.5, which is constant. Height of the flange is equal to 600 minus 21.3, that is 578.7 mm. So by substituting the values of I by beta f I by hf. So 1 minus 0.5 into 0.5 into I by 4702.5 into 10 power 4 into hf square 578.7 square. We know the value of 3.94 into 10 power 12 mm. So here, please listen. So pi square E 2 into 10 power E value is 2 into 10 power 5 Newton per mm square. So E pi square E 2 into 10 power 5 I by 4702.5 LLD 5000 G modulus of rigidity IT 1.8 into 10 power 6 again pi E value we know IW 3.94 into 10 power 12 and LLD. So substitute all the values in MCR square root. So by substituting all the values MCR, the value of MCR is 1300.77 into 10 power 6 Newton mm, that is 1300.7 kilonewton meter. So we will get the value of MCR as this one. MCR as 1300.77 kilonewton meter. So this is the one of the solving formula parameter. So we know MCR. Now it is easy to solve lambda LT. So it is easy to solve lambda LT, that is equal to beta B into ZP into Fi by MCR. So this is the MCR value here. So please listen. So by solving beta B value constant 1, beta B constant 1 and ZP value in the section considered, which is ISWB 600, 3986.66 into 10 cube Fi 250 by MCR 1300.77 into 10 power 6. So which we will get the value of 0.875. So beta B constant, beta B 1 constant, ZP plastic section modulus Fi 250 by 1300.77 into 10 power 6. So here a lambda LT we will get, but the lambda LT must be less than or equal to root of 1.2 into ZD into Fi by MCR. So here one of the condition is the lambda LT must be less than root of 1.2 ZD Fi. So root of 1.2 into same ZP value for ISWB is 3986. Elastic modulus for ZD was 3540 into 10 cube into Fi 250 by 1300.77 into 10 power 6. So which we will get the value of 0.9. This is 0.875. Hence, okay. So thus check should be solved. If in case it is not solved, please change the section. Okay. So we have got the value for lambda LT and MCR. But the design bending strength was the formula for design bending strength was different. Okay. So now after this parameter, we should calculate pi LT. So in design steps, I have told these all the formulas. Now pi LT is equal to 0.5 into 1 plus alpha LT into lambda LT minus 0.2 plus lambda LT square. This is the formula for pi LT. So here we know the value of lambda LT. So substituting 0.5 into 1 plus alpha LT for steel section and rolled section. So alpha LT is equal to 0.21 and 0.39 for steel welded, for rolled welded. So 0.21 we have considered, and 0.875 minus 0.2 plus 0.875 square. So by solving we will get the value of pi LT 0.95. So after getting the value of pi LT, so we should solve Xi. Already I have told Xi LT. So Xi LT. So Xi LT, the formula for Xi LT was 1 by pi LT plus pi LT square minus lambda LT square power 0.5 less than or equal to 1. So this is the value. So 1 by pi LT value 0.95 plus 0.95 square minus 0.875 square over 5. So the value of Xi LT was 0.76, which is less than 1. 0.76, which is less than 1.0, hence safe. So this is the value for Xi LT. So now we will get the main step for design bending strength. Now we will get the main step for design bending strength. So now design bending strength MD is equal to beta B into ZB into FCD. So we don't know value of FCD, that is the value for beta FCD is formula for Xi LT into Fi by gamma m0. So already we know the Xi LT value 0.76 into Fi 250 by 1.1. So we will get the value of 172.45 Newton per meter. So substituting the value for MD 1 into ZP value 3986.66 into 10 cube into 172.45. So by solving the value, we will get value 686.5 kilonewton meter, which is greater than 562.5 kilonewton meter. Therefore, MD greater than M and safe. So MD must be greater than M. So the design bending moment. This is the first formula. So please keep in mind. This is the first formula. Design bending strength. So we don't know FCD. After FCD, Xi LT into Fi by gamma m0. So if we want Xi LT value, we should solve this formula. While solving this formula, we don't know value of pi LT. So to calculate pi LT, we should solve this formula alpha LT. So alpha LT and lambda LT. So we don't know lambda LT. So we should calculate the before formula for lambda LT. Okay, lambda LT is nothing but root of beta B into ZP into Fi by gamma m0. So if we want lambda L0, we should calculate MCR. So this is the steps which we want to solve the laterally unsupported beam. If it is given for 14 marks, we can stop the formula and please keep in mind, last step should write. So hence it says, so you should write provide ISWB 600 at the rate 1311.9 Newton per meter as section. Should write this step. So this is the important step. So why? Because we are doing the problem to provide the section. So for the correction people or for the designers, we should keep the mind. They will not read all the problem. They will see the section which is safe or not. So For 14 marks, it can be enough for this. Up to this, if it is given for 28 marks, we should do the checks. So I have already explained for checks for laterally supported beams. So there are same steps for laterally: check for deflection, check for shear, check for web buckling, check for web crippling. These 4 steps same to same. Same for laterally supported and same for laterally unsupported beams. So please keep in mind. So laterally supported and laterally unsupported, which are easy to calculate. So these two methods, in these two methods, you can ask one method. Okay. So please follow the video and do the problem. I have kept the PDF already in your group. So please do the problem while seeing the video. As you said, I have solved step by step process only. So please listen the video and do the problem. If you have any doubts, ask me. Thank you.